Okay, this is going to be me going through the 2024 AS Pure Maths paper for WJEC. Okay, let's get into it. Question number one, we're going to start off with some nice straightforward differentiation. Remember, you've got to show all of your working, so even though your calculator can give you the answer to question one in its entirety, you need to show all of your working out. So let's get into it. So dy by dx, the gradient function, it may be worth, before launching into that, actually rewriting the function as 12x to the power of a half minus 27x to the power minus 1 plus 4. That might make it easier for you to differentiate. And remember, the rule for differentiation of polynomials is you multiply by the power, take one off the power. Okay, so we're going to have a 12 times a half, and then we're going to take one off a half to give minus a half. Then for the next one, we're going to have the minus 27 multiplied by minus 1, and then we're going to take one off the power to give us x to the minus 2, and the derivative of 4 is 0. So we don't need to do it here, but I am going to do a little bit of simplification. 6 times x to the power minus a half plus 27x to the power minus 2. Evaluate that then when x is 9, so the gradient when x is 9. So 9 to the power of minus a half is the reciprocal of the square root. So the square root of 1 over 9, which is 1 over 3. So I'm going to have 6 over 3. And then 9 to the power minus 2 is 1 over 9 squared, which is 1 over 81. So plus 27 over 81. And this first term is 2. 9 goes into the top and 9 goes into the bottom. In fact, 27 goes into the top and the bottom. So I get that. So 2 1/3 or 7 over 3. Hopefully that's what you get from your calculator as well. So yeah, there is a function where it will differentiate and evaluate that derivative for you at a given value. So make sure you make use of that. Find all the values that satisfy that equation. So we'll start off by making sine 2x the subject. One thing to pay attention to here is the values of theta that I want my answers between. So you don't need to go as far as 360 here. So I can say that 2 theta then is inverse sine of a half, which hopefully everybody knows is 30 degrees. And then the next solution after that is going to be 150. You may want to think of your sine curve like that. Here's our first answer. There's our 30. Our next answer is over here, which is 30 away from this root at 180, which is where the 150 comes from. Now you always need to think, do I need to continue finding alternate solutions? And if you did, you would just add 360 to each of these. But then you need to realize that when you half those, they'll already be bigger than 180. So actually, no, there's no need to go any further. So theta is going to be 15, which is 30 divided by 2, or it's going to be 75, which is 150 divided by 2. There we are. So 7 marks on that first page. Really nice introduction to this paper. Going to move on. Another little bit of calculus close to the start of the paper. That's quite nice. Integration here. So we're going to do the reverse of differentiation, which is now add 1 to the power, divide by the new power. So for this first term, I'm going to have 5x to the power of 5 over 4 divided by 5 over 4. The next term, we're going to have 3x to the power minus 1. Be careful when you add 1 to minus 2, you don't get minus 3, despite what a lot of people try to tell us. Divided by the power, which is minus 1, minus 2x to the power. You can put the 1 in there or not. And remember, because it's integration, we need that constant of integration. Okay, a little bit of tidying up. We don't need to do this, but it's always good form to do a bit of tidying up. So I'm going to have 4 lots of x to the power 5 over 4. Remember, dividing by 5/4 is like multiplying by 4/5, and so the 5 on top and bottom cancel out. Minus 3x to the minus 1 plus 2x plus c. If you wanted to be fancy with this term here and write it as minus 3 over x, you absolutely could. There'd be nothing wrong with that at all, but there is my answer. Plus c, really important, remember. Given that n is an integer between 1 and 6 inclusive, prove by exhaustion that. Okay, so we're going to have n, I'm going to do 1, 2, 3, 4, 5, and 6. Then the expression that we want to deal with, n squared minus 2, and then divisible by 3. This is just going to be a tick or a cross column, hopefully all crosses. So 1 squared minus 2 is going to be minus 1. 2 squared minus 2 is 2. 9 minus 2 is 7. 16 minus 2 is 14. 25 minus 2 is 23. And 36 minus 2 is 34. Well, that one's not in the 3 times table, nor is that one, nor is that one, nor is that one. No, no. Okay. Therefore, for n being an integer and 1 is less than or equal to n less than or equal to 6, n squared minus 2 is not divisible by 3. Okay, now you may think this sentence at the end is a waste of time because I'm just basically repeating the question, but that is how you need to finish these questions. Okay, moving on. Right then, a little bit of triangle geometry here. So before I do any sort of thinking about how I'm going to solve this question, I'm going to draw myself a picture. A, B, C. You'll notice that I didn't take any care whatsoever to look at which one's the longest side, which one's the shortest. I just want a triangle. AB is 6, BC is 11, AC is 13. So you can see clearly this isn't to scale in any way at all. We now are going to go back and read the question, calculate the area. Okay, so I know that area is half AB sine C, so I need to know the lengths of 2 sides and the angle between them. Now I don't have the angle between them, which makes me think that I'm going to go down the cosine rule route as well. So let's pick an angle to find. Let's find that angle theta. Okay, then if we think about leaving up our triangle, that's little a, that's little b, that's little c. So let's think about the cosine rule. It says that a squared equals b squared plus c squared minus 2bc cos a. Let's translate that to being in terms of the numbers and letters in our question. So we're going to have 11 squared equals 13 squared plus 6 squared minus 2 times 13 times 6 times cos of theta. If you already know the rearranged version and want to go straight ahead and use that, that's absolutely fine. Nothing wrong with that at all. I'm going to then rearrange this. I'm going to rearrange it into the form where I've got a positive denominator. So I'm going to have 13 squared plus 6 squared minus 11 squared, and then 2 times 13 times 6. So if you work all of that out, you can say that cos theta comes out as 7/13, I think. Now, in this question, it says calculate the area. It doesn't specify that the area we need to find is exact. However, if it did say exact, what I would be encouraging you to do here is use the relationship. I'll use a different color pen for this. I'd be recommending that you use sine squared theta plus cos squared theta is equal to 1, and then you can work out that sine squared theta plus 49 over 169 equals 1, and you can work out sine theta that way. So sine theta would be, and because we're going to be dealing with acute angles here, we can ignore the negative. It would be the square root of 1 minus 49 over 169. So the square root of 120 over 169, and then you could sub that back in. And in fact, that is what I'm going to do. So the square root of 120 over 13. Okay, what you'll find a lot of people do, most people to be honest, they would then find theta by doing inverse cos of 7/13 and either leaving it like that or working that out as an angle. And just for the sake of completeness, I'll give you that is 57.4 degrees. But like I said, I'm not going to use that. I'm going to use what I did in green. So I can then say that the area is equal to 1/2 multiplied by, well, the two adjacent sides, 13 and 6, and then sine of the angle, which is root 120 over 13. And you can see some nice things happening here. So we get a 3 there. So 3 lots of the square root of 120. Root 120 is 2 root 30, so this is actually going to be 6 root 30, which is approximately equal to 32.86, and because we know the units, we really should use them. Okay, so there's my approximate answer. That first one there would be my ideal answer in exact form. There's no requirement to do that here, but it means you can do this question without a calculator, which is always better, in my opinion. Moving on to the next question. Okay, so it's an indices question here. First one looks a bit different, which is nice. So let's deal with the left-hand side first. We're going to have 7 and then x to the power 5 over 4 minus 1 over 2. Hopefully we remember that rule of indices. And then let's think about the right-hand side. Now, I don't know if it's just me, but when I see the number 147, I immediately think of 49 times 3. So that can be rewritten as 7 root 3, sorry. And then can cancel those 7s. So 5 over 4, take away 1 over 2. Well, that's 5 over 4, take away 2 over 4. So 3 over 4. And that's equal to 3 to the power of 1/2. Okay, and then we've got to think, well, how can we deal with this one now? Well, the opposite of power 3 is cube root, so I can divide the powers on both sides by 3 and then multiply the powers on both sides by 4, which is equivalent to doing the cube root and then the 4th power. So if I do it one step at a time, if I cube both sides, I'm going to have no, that's wrong. If I cube both sides, I'm going to have that, cube root both sides, sorry. And then if I raise both sides to the power 4, I'm going to have 3 to the power 4 over 6, which we know is 3 to the power 2/3. And there's my answer. And then the third question. Now I remember when I first did this one, it caused a little bit of a stir. But let's go ahead and have a go at it now. So my first instinct when I first got this was to look at the top and notice that it's got a common factor of 2. Okay, over 2 root x minus 3. And then particularly because of the form that the denominator takes, I kind of looked at the bracket, the factor here, as a difference of 2 squares because of the 4 and the 9. So remember, if you have a squared minus b squared, that is a plus b, a minus b. Okay, so we've kind of got that form here. I know it doesn't look like a lot of ones you've probably seen during your lessons, but it is. Okay, so the square root of 4 is 2, so I know I'm going to have a 2 and a 2. The square root of 9 is 3, so I'm going to have a 3 and a 3. And then instead of what we would normally have, which is something like an x squared here, so we'd have an x in both of our brackets, well, we've only got an x, so what we're going to have in each of our brackets is a root x. Okay, and then we've got 1 plus and 1 minus. So just because I haven't got x squared here, which is what we would normally expect to see, doesn't mean I can't use complete difference of two squares. Okay, and then I've got 2 root x minus 3, and that's really, really nice because that factor there and that factor there cancel, leaving me with exactly what I wanted. Only if I write it correctly though. There we go. Okay, now there are other ways to get there. I think the very first time I did this, I think I tried to rationalize the denominator by multiplying top and bottom by 2 root x plus 3. And I think there is some merit to that, but I found this way a little bit easier. Okay, moving on to the next question. Okay, right, into our first coordinate geometry question. We've got a line L1 and it passes through both those points and they want the equation. So remember, to find the equation of a straight line, you need to know its gradient and 1 point on the line. We've got 2 points that lie on the line here. So let's find the gradient of the line segment that joins them. So going from A to B, the y-ordinate goes up by 4, and going from A to B, the x-ordinate goes up by 4 as well, meaning the gradient is 1, which means the equation of the line AB can then be written as y, and I'm going to use point A here, so y minus y1 equals mx minus x1. Okay, and so y minus 0 is just y, 1 lot of x is x, 1 lot of the negative of minus 3 is plus 3. So that's a really nice 3 marks for us to have gotten there. Given that L1 and L2 intersect at C, find the coordinates of C, and we've got the equation of L2 there. So let's get straight into that. Y equals x plus 3 and y equals 3x minus 3. Well, let's write 3x minus 3 equals x plus 3. So 2x is going to be equal to 6. X equals 3. And if x equals 3, that tells us y is equal to 6. Therefore, point C has coordinates 3, 6. Line L2 crosses the x-axis. Okay, so on the x-axis, y is equal to 0. Show that the coordinates of D are that. So we know that at that point, 0 equals 3x minus 3, 3x equals 3, x equals 1. Therefore, D is the point 1, 0 as required. Okay, so another very kind 4 marks there. That's really, really nice. So there's probably a part C and maybe even a part D coming, but 7 of the marks in this question are really, really nice ones. So it doesn't really matter what comes next. We've done a good job getting these 7 marks. I'm going to move on to part C. And it's quite a nice part C, actually, finding the area of a triangle. What we probably want to do, and I'm glad we've got a little bit of space up above, although down below is better because there's no lines. It's a good idea to draw these lines, I think. So this one here is L1. Okay, passing through the point 3. Here is the point A. Here is the point B. Then we have the line L2. Let's imagine that's a straight line there. This is L2. The point where they intersect here is C, and the point D was 1, 0, so that's this one here, that's point D. They want us to find the area of the triangle ACD, which is this one here. Now, by all means, if you want to start doing sine rule, cosine rule, all that kind of stuff, you can find the lengths of lines. But all you really need to realise, and especially for the fact that it's only 2 marks for this question, is that the area of a triangle is base times height divided by 2. And so if we can find the length of this base, if we can find this perpendicular height, then we can do it. Okay, so to find the length of the base from A to D, if we consider the coordinates of A, so -3, 0, and the coordinates of D, which I think was 1, 0, which was what we found, the distance then AD is 4. Okay, the perpendicular height, so if that's a 4 there, is just the distance from C to the x-axis, so we just need to look at the coordinates of C, which I believe were 3, 6. Okay, and so this perpendicular height here is just 6, as in the y ordinate, which means the area of the triangle A. I think I just muted myself then. The area of the triangle ACD is equal to 1/2 times 4 times 6, which is 12 square units. Okay, and so this is an example of a question where drawing yourself a decent diagram, I'm not going to say my diagram's perfect because one of my straight lines is curved, but drawing yourself a decent diagram just so you can get a feel for what's going on can save you an awful lot of hard work. I've seen lots of students do this question using lengths of lines, like I said, sine rule and cosine rule, which is way harder than what you actually need to do. Okay, moving on to the next question. Okay, there's a part D that I wasn't expecting. So what I'm going to do is I'm going to get my picture from the last page and bring it over. Okay, so they do often like to finish off a question with an angles one, which means we now will need to know some lengths of sides. So we've got the 4 and the 6 already there, and I'm thinking of trying to break this into right-angled triangles, so you hopefully can see that we've got a little right-angled triangle here, and then we've also got a bigger right-angled triangle here. Okay, and so concerning just the big right-angled triangle to begin with, I can see the vertical height of it is 6. I can see part of the base from A to D is 4, and remember the coordinates of D were 1, 0, and the coordinates of C were 3, 6, which means this distance here must be 2. Okay, so I can actually work out tan of, if I name this point down here, let's call that x, I can work out tan of ACX, which is 6 over 6, which is 1. So that means I can work backwards and find out what that ACX angle is. Then if I look in this smaller right-angled triangle, well, I also now know the 2 shorter sides, so I can work out tan of DCX, and that is going to be, oh, sorry, there's a train going past, that's going to be 2 over 6, which is 1/3. Now, the angle ACD, okay, so angle ACD equals
the difference between those two. So ACX minus, what did I say, DCX. Okay, so that means that the angle that I want is the same as arctan of 1 minus arctan of 1/3. And when you plug that into your calculator, making sure that you're in degrees mode, what you should get is 26.57 degrees. Okay, now the reason I do it this way is because I think this is the easier way to do it. You could find in the triangle that I've coloured in blue, you could find the length of BC and the length of DC. Not BC, AC and DC, and then you could use the cosine rule if you wanted to. But for only 2 marks, it made me think that there was probably a simpler way. Okay, going to move on to the next question. So we've got what looks like a quadratic inequality here, and we're trying to prove that the right-hand half is greater than the left-hand half for all real values of x. So you might not have much of an idea where to go here, but what you should have is a bit of intuition, or maybe some even rote memory, to know that when you see quadratic inequalities, get everything on one side and get a 0 on the other. So that's where I'm going to start. I'm going to leave the x squared positive, then I've got minus 5x. I'm going to subtract x from both sides and add 10 from both sides, and then that is going to be greater than 0. So x squared minus 6x plus 10 is greater than 0. So if we want to prove that our original statement, this one here, is true for all real values of x, then that is exactly the same as proving that this quadratic expression is greater than 0 for all values of x. And that should be making you think about completing the square. Okay, you could, I suppose, do some calculus with it if you wanted to, use the discriminant, maybe. Actually, calculus is not the best way forward, but you could use a discriminant if you wanted, but my brain goes straight away to completing the square. So I'm going to have x minus 3 all squared. Remember, you subtract the square of the number in the brackets and add 10 is greater than 0. So then I've got x minus 3 all squared plus 1 is greater than 0. Okay, so I've now got it in completed square form. How do I prove that that is greater than 0? Well, I know when I've got something in completed square form, this number here is either the maximum or the minimum value. And because we've got a happy parabola, a positive quadratic here, I know that the value, the plus c on the end, is the value of the minimum. So I'm going to say that this has a minimum value of 1, therefore always greater than 0, therefore statement is true. For all real x. Okay, because remember, we started with our original, we rearranged it, and it meant we got to the point where we said proving the one I've highlighted in yellow is the same as proving that, which we then went on to do. We went on to prove the red starred thing, which meant our original yellowed out inequality must be true as well. Moving on to the next question. Okay, binomial expansion question. I like these. So 2 minus x to the power 6, we only need to go up as high as the term in x squared, which means the first 3 terms. So this is approximately equal to, well, if you think how many possible ways are there of picking those 6 2's when you make 6 picks? Well, there is only one. times 2 to the power 6 over 0 factorial. So I'm including every single part of this, even though you may not put the 0 factorial in, it is still there. The second term then, so I'm going to do 6 choose 1, which is 6, and then I've got 2 to the power 5, I've got one lot of negative x, and then that's over 1 factorial. And then the next one, I'm going to do 6 choose 2, which I know is 15, and if you know Pascal's triangle, you'll see that these are just the coefficients from one of the rows. 2 to the power 4 times minus x squared over 2 factorial. And then obviously there's a bunch of other terms, there's 4 more terms as well, but we don't need to work them out. So 2 to the power 6 is 64. Then we've got 2 to the power 5, which is 32, times minus x. So minus 32x times 6 is minus 192 lots of x. And then for the third term, I can see it's going to be positive again, because I've got 2 negatives multiplied by each other. Then I've got 2, 4, 8, 16. Divided by 2 gives me the 8. And then I'm going to multiply by the 15, so I get 240 x squared. And there are my 3 parts for my 3 marks. Okay, moving on. I suspect there's a part B. And here we are. Find the values of the constants A and B. So really important to note, this thing here is what we've just dealt with. Okay, so let's start there. Let's think that what we've actually got is 1 plus ax multiplied by our answer from the previous question, so 64 minus 192 lots of x plus 240 lots of x squared. Okay, and then if we look, and I'm hopeful, yeah, I should have enough colours for this. This 64 here, okay, is going to come from this 1 multiplied by this 64. Okay, now that's not particularly helpful to us, so I'm not going to waste a colour of highlighting on that. Let's think instead, where is this bx going to come from? Well, where do x terms come from? Well, they come from this one multiplied by this one, and then they also come from this one multiplied by this one. Okay, so I can write myself a little equation now saying that, and I'm purely going to look at the coefficients, so we're using the technique called comparing coefficients. Okay, and if we're looking at the x coefficient, I normally write down which coefficient I'm looking at and put it in a little circle. I know that b must be the same as 1 times minus 192 plus a times 64. Okay, now I'll probably rewrite that as 64a minus 192, and there's not really much I can do with that at the moment. It's a true statement, but not particularly helpful at the moment. So call that number 1, and we'll move on. Let's go to a second colour. Let's go to blue. The only one I've got left is this 336. And let's think now, where do x squareds come from? Well, x squareds are going to come from the x squared term in the second bracket multiplied by the constant in the first bracket. And they're also going to come from the linear term in the second bracket multiplied by the linear term in the first bracket. So now I can write a second equation down. So I'm now looking at x squareds, and I can say that 336 is going to be equal to the product of 1 and 240 and minus 192 times a. So minus 192a. So I can say that 192a equals 240 minus 336. 336, which gives minus 96. So A is minus a half, because minus 96 over 192 is minus a half, which then allows us into number 1, sorry, which allows us to work out that B is equal to minus 32, which is minus a half times 64, minus 192, which I think is minus 224. Yeah. And there we go, 6 marks there. Okay, moving on. Right, so some water into a tank. Y is the depth of the water, T is the time. This little statement at the end about T being between 0 and 7 might be important, because we might solve an equation later and get T equals 8 out, for instance, and we'd know that we can ignore that. I do know on this question that they were super strict about at least the first 3 marks. If you don't show your working out, this is one of the instances where you are going to get clobbered for marks if you just get to the 2 solutions, which end up being 2 and 12, and we'll see that in a sec. Yeah, you're not going to get many of the marks, so you must show your working out. It's really important. Always show your working out, but there are some places where it's particularly important because you will definitely lose marks, but you never know where those are when you're doing the test. Okay, so find the value when the depth of the water is 25. Well, what that means is T squared minus 14T plus 49 equals, and we've been told that the depth, which is Y, was 25, meaning we've got a quadratic here that we're going to end up solving. That's 24 equals 0, and this is where those 2 numbers I said a minute ago came from. Multiply to make 24, add to make minus 14, so I'm going to have minus 12 and minus 2 and a T and a T. Therefore, T equals 2, T equals 12. Okay, and remember I said why I highlighted the bit in green, we might get to a point where we get a solution bigger than 7 and ignore it. Well, this is that point already, so you need to explicitly say that the answer is T equals 2. If you leave them both there, then you are not going to get the 3rd mark. The word rate in part B, when you see that word, your brain should immediately be thinking of calculus, rates of change, derivatives, all that kind of stuff. And so we're going to calculate dy by dt, which is the rate of change of the depth with respect to time. So we're going to get 2t minus 14. So that quantity there tells you at a given time how is the depth of the water changing. As you can see that for small values of t, it's going to be negative, but then when t is very big, you're going to get a large increase. Okay, so we're told when t equals 3, so dy by dt. When t equals 3, well, I'm going to get 6 minus 14, which is minus 8. Let's contextualize that. That is then in centimeters per second. Sorry, there's another train there. Therefore, and remember the question asks for a decrease. Now, if you have a decrease of minus 8, that's actually an increase, so it is best for you to say decrease is 8 centimeters per second. Okay, you may get away with an answer of minus 8, but it does specifically ask for a decrease, so the answer technically is that 8. Okay, let's move on. I was expecting more to that previous question. Sketch the graph of 3 to the x. Now this should be a gift of a mark for the vast majority of people, or everybody to be honest. All exponential graphs, when you've got a base greater than 1, are going to look like that. Okay, the only time you need to worry about how they look different from each other is when you're plotting more than 1 on the same graph, and the bigger the base, the steeper it is. Okay, clearly label the coordinates at the point where the graph crosses the y-axis. It always crosses through 1 because that is the point when x equals 0, and so you want to consider 3 to the power 0. And from the rules of indices that you should know that anything to the power 0 is 1. Okay, so this is the graph of y equals 3 to the x, and this is my x-axis, and this is my y-axis. On the same set of axes, sketch the graph of that. Okay, now you may not have seen something like that in your lessons, so you've got to think, well, how can I turn it into something that I know a little bit more about? One thing I've got to say about part A actually is it's important that you remember that this negative x-axis here is actually an asymptote, so the graph approaches it but never crosses it. So back onto part B, I'll stop jumping about now. You may want to think of this as 3 to the power of x multiplied by 3 to the power 1, which can then just be written as 3 multiplied by 3 to the power of x. So you can just see then that this is a transformed version of the graph that we just drew. Okay, so I'm going to draw it in a different colour. And the transformation is a vertical stretch with a factor of 3. So it's still going to approach 0 as x gets very large and negative. However, the difference is now that it's going to, instead of passing through 1, it's going to pass through 3. And so let's try and draw a nice smooth curve here. Got to pass through 3. Nice curve. So that happens to me all the time when I'm doing exams, and what I do is, rather than rubbing out the curve, because that's the difficult bit to change, I'm just going to move where I said 3 was on the y-axis. That feels like cheating, I do appreciate that, but it's easier than moving the curve. What's really important is that kind of the horizontal distance, if you like, between points on the curve looks about the same, so that line and that line and this line are all about the same length. We don't want to make it look like these graphs are getting further apart, because they're not. That is going to remain constant. So I can't make the blue one doesn't get much steeper, much quicker. They stay about the same distance apart. Okay, going to move on. On to the question now that maybe lots of people have been waiting for, finding and classifying the stationary points on a cubic. So this, hopefully, by this point in your education, is kind of, you got this off pat. This is muscle memory. Your hand is writing before you've had to think too much about it. Just thinking about doing this question, it is telling me there are multiple stationary points. So I'm suspecting, and you've seen by this point, that they always come in pairs. You have one maximum and one minimum. The other thing that I do want to draw your attention to is the fact that there's a minus in front of my x cubed. So you're probably used to seeing loads of examples where the stationary point with the smaller x ordinate is a maximum. This has now got a negative in front, so they're going to be the other way around. That's just something to bear in mind. You can't ever just state that, or you shouldn't ever just state that. We're going to prove it, but it's just something to keep in your head. So dy by dx, the gradient function, I'm going to have minus 3x squared plus 12. At stationary points, I know that dy by dx is equal to 0. Therefore, minus 3x squared plus 12 equals 0, which leads us to 3x squared equals 12, x squared equals 4, so x equals plus minus 2. When x equals 2, y is going to be equal to, well, you just stick it back into the original equation that you've got, and you should find that y is minus 4. When x is minus 2, you again stick it back into the original equation, and you should find that y is minus 36. So at this point, I like to do a little in the middle of the question summary. Therefore, stationary points at xy is equal to 2 minus 4, and minus 2 minus 36. So now we found where they are, let's classify them. And there's a bunch of different tests you can do for this. I like to do the second derivative test. So d2y by dx squared. This is the rate of change of the gradient. And so I'm going to differentiate again to give me minus 6x. d2y by dx squared evaluated when x equals 2. Well, that's going to give me minus 12, which is less than 0. And remember, when the second derivative is less than 0, that means the point you're looking at is a maximum point. Therefore, maximum. And that is at the point 2 minus 4. It's not okay then to just go, well, because that's a maximum, the other one must be a minimum. Let's prove it. Evaluated x equals minus 2. Well, we're going to get positive 12, aren't we? Positive 12, which is greater than 0. Therefore, we can say a minimum is at the other point, minus 2, minus 36. Okay, and that is our 7 marks. I love doing those questions. Considering that took us about 3.5 minutes, we did that question really quickly. Moving on. Determine the range of values for which the curve is decreasing. So you should remember that increasing and decreasing refer to the gradient of a function, and a curve is decreasing when the gradient is less than or equal to 0. Okay, it's strictly decreasing when the gradient is less than 0, so decreasing is less than or equal to 0. So we've got an expression for the derivative, haven't we? We've got minus 3x squared plus 12 is less than 0. X squared is less than 4. Okay, so let's then consider the critical values. Well, the critical values are going to be plus minus 2. And then hopefully you do what your teacher told you to do. You draw yourself a little quadratic curve where that is 2 and that is minus 2. And you think, well, where is that less than 0? And it's less than 0 for this bit and this bit. And the values of x that go along with that are all of these ones or all of these ones. So I have that x is... there we go. I put strict inequalities rather than inclusive ones. So I've either got x greater than or equal to 2, or I have x less than or equal to minus 2. Now I've gone back and done all of that work again. You don't need to, do you? Because we've already found these 2 and minus 2 in the previous questions. So you could have taken those from there, and then you've just got to figure out whether it's greater than or less than, or whether it's one inequality or 2. It then does ask for the answer to be given in set notation. And so what we want is, this means x belongs to the set of numbers. So less than or equal to minus 2 means it can go down as far as minus infinity up to minus 2 with our square brackets. Or the set notation for that is this union, and then I can go from 2 up to infinity. And there is my answer. I'm just going to underline them. And we'll move on.
Okay, we'll move on to question 13. And the vectors question. Find the vector AB. So remember, AB is the same as B minus A, the position vector of B, minus the position vector of A, which in this case is 1, 3. If you choose to use column vectors like me, minus 4, 7. So 1 take away 4 is minus 3. 3 take away 7 is minus 4. So that is the vector AB. The common mistake here is getting them the wrong way around, so doing A minus B, and in that case you would get 3, 4, which obviously isn't the right answer. I'm sure you would gain 1 mark out of 2 for doing it though. the distance between points A and B, so that is the magnitude of vector AB. Okay, so AB, and that is the square root of the difference between the I components and j components. So from 4 to 1 is a jump of 3, and from 7 to 3 is a jump of 4. Now you can see I've been very, well, I haven't worried at all about the signs there. I've just dealt with the positive ones, and that's because when we square it, it's not going to make any difference what the signs were. That's square root 25, so the distance is 5 units. And there we are. We'll move on to part C. I'm sure there'll be something about a position vector of, oh, another train. Very busy today. The position vector of point C is given by that. The point D is such that it's equal, and C and D is parallel to AB. So what you might want to do is you might want to do a little bit of a sketch. So relative to some kind of origin, vector A was, I forget, 4, 7. So over here somewhere. So there's point A, and there's vector A. Vector B was 1, 3. So maybe somewhere like that. There's the vector B, and so this vector here, I can draw it a bit more accurately. I know it's wobbly, but there we go. That's the vector AB, and we know that the distance from A to B is the same as the distance from C to D. So if we now have a point C which is minus 2, 5, so that'll be somewhere over here. I know that the point D is either going to be here, or, because it does say possible positions, or it could be there. So it could be C plus 1 lot of AB, or C minus 1 lot of AB. So I'm going to have points D1 and D2. So the position vector D1, and I'm going to use the little D1 for this. So D1 could be the position vector of C plus AB. Okay, oh no, that's going to give us D2. So minus AB. Okay, because remember AB is this. Okay, so that is AB, and that is negative AB. Okay, so we will have the position vector minus 2, 5, take away, and if you think what AB was, it was minus 3, minus 4. So I'm going to close my window. There's a dog. Minus 2 take away minus 3 gives you 1. 5 take away minus 4 gives you 9. So that's one possible position vector of D. The other one is going to be the position vector of C plus AB. Didn't put my vector notation. So minus 2, 5 plus minus 3, minus 4, which will give us minus 5, 1. And so those are my two potential position vectors of the point D. Okay, going to move on. Write down the coordinates of A and B. What have we got here? So we've got some kind of quadratic intersecting with a curve. Okay. So the graph clearly shows us that the coordinates of point A are 0, are something 0, and the coordinates of B are 0 something. It feels too easy to just sub those in, but it does say write down. Okay, so coordinates of B, first of all, that's nice and easy. When x is 0, y is 2. And then A, when y is 0, x is minus 2. Okay, that feels a bit straightforward. Sorry, that's the reason I'm pausing. And so if the next question is anything to do with integration, what we've just found more than likely are the limits of integration. So let's move on and see. Find the area enclosed by C and L. So I'm going to make a picture appear. There we go, as if by magic. So the phrase enclosed by, hopefully you know that that means between. So we're looking for any area that's between the curve C and the line L, and that is this bit here. Oops, it is moving it. So that is what we want. We know the x ordinates of the points A and B. So we can do this, I think. Now, I've always done this purely by integration. Some of you may decide that you would like to do it as a triangle, using that gold triangle there. I'm not going to do that. I'm going to do it using just a straightforward integration. So I'm going to find the area under the curve. So 2 minus 3x minus 2x squared. So that will give me the blue area and the gold area because it's everything under the curve. And then from that, I'm going to subtract the area under the line. So x plus 2. And that's with respect to x. And I'm going to integrate between minus 2 and 0. Okay. Now, because I know this is going to give me the blue area and the blue area is above the x-axis, I'm going to call that A, which is what we want. If I wasn't sure whether a positive or negative answer was going to come out, I'd probably just call it I for integral and then interpret it at the end. So I can say that A now is the integral between minus 2 and 0 of, well, the minus 2 and the 2 are going to cancel, and I'm going to end up getting minus 4x minus 2x squared dx. Okay, both of those are terms that we know how to integrate. So when I divide integrate minus 4x, I'm going to get minus 2x squared. When I integrate minus 2x squared, I'm going to get minus 2/3 of x cubed. But my limits are minus 2 and 0. Okay, so when I put 0 in, I'm going to get 0. When I put minus 2 in, well, I'm going to get minus 2 times minus 2 times minus 2, which is minus 8. Then I'm going to get minus 8 times minus 2, which is plus 16 over 3. Okay, now the bit inside the brackets will give me minus 8 over 3, and so this gives me an answer of 8 over 3, and you can call that units squared or square units. I think that's very nice for 6 marks. If you did just want to do this bit here, okay, that would then give you both the blue bit and the gold bit on my diagram combined. Then you would find the area of the golden triangle by doing base times height divided by 2, and then you would do a subtraction at the end. It has exactly the same effect. Neither of the methods is better than the other. You're doing pretty much the same maths. I've just always found this one easier personally. Moving on. Question 15. So we got a bit of trig going on here. So find the value of x at each of the points A, B, and C. So let's just circle them. I want A and B and C. I dare say that the equation I solve is probably going to give me O as well, but I just need to remember that that's not actually part of what I'm being asked. So I'm considering the equation 3 cos squared of x plus 2 sine of x minus 3 equals 0. Okay, because they're all on the x-axis, which means the y value is 0. This now feels like a fairly straightforward question. 1 minus sine squared of x plus 2 sine x minus 3 equals 0. The 3 I'm going to get from the brackets and the minus 3 cancel out. So I'm going to get 2 sine x minus 3 sine squared of x equals 0. Factorize out sine x, and I'm going to get 2 minus 3 sine x equals 0. So my two branches of solutions are going to come from the solutions to that equation and that equation. Okay, this one boils down to 2/3. Okay, so from let's color code them now so we don't lose track. If that's the blue one and that's the green one. So from the blue one, I'm going to do inverse sine of 0. So I'm going to get x equals 0 degrees or 180 degrees or 360 degrees, and you can keep going if you really want. From the green, we're going to do inverse sine of 2/3, and what you're going to get is 41.81. And you're going to take that away from 180, so you're going to get 138.19. And then you could go further and add 360 to each of those, but we don't need to. So looking at O and A and B and C, it looks like this one is point O, the next one here is point A, the next one here is point B, and this one then will be point C, and that's purely from looking at the order from smallest to biggest, because that's what O to C does. So we would say that A is 41.81 degrees, B is equal to 138.19 degrees, and C is equal to 180 degrees. I know there will have been a lot of people who will have put 0, 41.8 and 138.19, but yeah, there we are. And we'll move on to the next question. Okay, let's move on to question 16. Find the range of values of k for which this has no real roots. This phrase here, no real roots, should immediately make you think of one thing, which is the discriminant. Okay, and remember b squared minus 4ac. And if something has no real roots, that means the discriminant is less than 0. So we have a is 1, b is minus k, and c is positive 4. So let's go ahead and put that into our discriminant. So b squared k squared minus 4 times a times c is less than 0. K squared minus 16 is less than 0. K squared is less than 16. Okay, so if you think of a graph of k squared, okay, or x squared, if you imagine drawing a horizontal line here at 16, well, you should know that you're going to get 4 and minus 4 is your critical values, and it's underneath that in between 4 and minus 4, so we're going to get k is less than 4 but greater than minus 4. Cool. Determine the points of intersection of those. So points of intersection are where the graphs intersect with each other, and where we have these two functions equal to each other. So x squared minus 4x minus 12 equals 0. Two numbers that multiply to make minus 12 and add to make minus 4. Feels like minus 6 and 2 to me. So we get x equals minus 2, x equals 6. And then to each of the x values, you're going to add 16 to get the y values. So you should get 22. So points of intersection are x, y is equal to minus 2, 14 and 6, 22. And there we have a really lovely 8 marks in under 3 minutes. Moving on to question 16, part C, I think. It gives us a pretty big steer here. We're going to use what we did in part A and B to sketch the two of those on the same axes. So we're going to have a big set of axes like this. If we look at the quadratic, it takes the same form as what we were given. Oops, I had to highlight that. The same form as what we were given in part A, and that minus 3 is in that range that was in our answer. So we know that this thing has got no real roots. So when we sketch this, we know that it's going to be a happy parabola going through 4 on the y-axis, and so it will look probably something like that. Then the other one is a straight line with positive gradient going through 16, and we know that the line and the curve intersect twice. I don't know what other information. For 2 marks, I don't think we need to put any other information on. Oh, yeah, it's another train. I'm going to mark down some of these, and then these 2 points are the ones we found in the previous part. So this is minus 2, 14. And this one here is 6, 22. There we are. And we'll move on to question 17. Everybody loves a logs question. And this one doesn't look particularly nice, but I promise it's not as bad as it looks. So we know the point c, 1 lies on f of x. So remember the first one, c is an x value. The 1 is a y value or an f of x value in this case. So we can say that 1 is equal to log to the base 10 of 2 minus c. The opposite of log to the base 10 is raising both sides to the power 10. So we get that 2 minus c equals 10 to the power 1, which is 10. And so we can see from that that c is going to be minus 8. 2 take away minus 8 gives you 10. And that's it. It's not as big and scary as you might think. Part B. Point P lies on that and has x coordinate alpha. Another point Q lies on that, also has the x coordinate of alpha. The distance between them is 1.2. Find the value of alpha. Okay, right then, as if by magic, pictures appeared. So what we've got here is we've got 2 points which both have the same x ordinate of alpha, and we know the distance between them is 1.2. So I'm just going to pick 2 points that lie on the same vertical line, and I'm going to pick these 2 points. So I'm going to say there and there, and I'm going to say that that is alpha. Now, it doesn't matter if I'm right or wrong. It doesn't matter whether alpha is something much, much bigger or much, much smaller. This is illustrative only. And so I know, or we know, that that distance there is 1.2. So that means this y value here subtracted from that y value there is 1.2, and we know how to work out the y values. For the g of x function, we know it's log to the base 10 of 5 minus your x value. And if we subtract from that log to the base 10 of 2 minus your x value, so this bit here is g of x, this bit here is f of x, and the difference between them is what this question is about, and we know that's equal to 1.2. Now, because we've got two logs with the same bases here, we know we can use the log rules. So log to the base 10 of 5 minus alpha over 2 minus alpha equals 1.2. Therefore, 5 minus alpha over 2 minus alpha, same as we did in the previous question, is 10 to the power 1.2. So I'm going to get now 5 minus alpha equals 2 times 10 to the power 1.2 minus alpha times 10 to the 1.2, and hopefully you can see where I'm going with this. I'm going to try and get all the alphas in the same place, all of the numbers in on the other side, and then solve. So I'm going to bring all the alphas over onto the left. So I've got alpha times 10 to the power 1.2 minus alpha equals 2 times 10 to the power 1.2 minus 5. If I then factorize out alpha from here, I've got 10 to the power of 1.2 minus 1. So I can then say that alpha equals 2 times 10 to the power of 1.2 minus 5 over 10 to the power 1.2 minus 1, which is the blue bit. And if you work that out, you should get 1.798. Okay, so you can see as far as the picture that I drew, I was a little bit off. I should have been a little bit more to the right. But at the end of the day, that didn't matter. Okay, now that is a hard question. That is a difficult question. Don't beat yourself up if you're finding that hard. There's a lot going on there, so take your time, pause the video, look back over it, and if you've got any questions, just feel free to ask. Moving on to what I think is the last question. Yeah, question 18. Circle geometry. Okay, a circle has centre, that, and radius, that. Show that it can be written like that. Well, we know that the equation of a circle is can be written as x minus the x ordinate of the centre, so x minus minus 3, all squared. Same thing for y, y minus, and in this case minus 1, and then that's equal to r squared. Okay, so I've got x plus 3 all squared plus y plus 1 all squared equals 5. To be honest, I normally wouldn't write that first line. I'd go straight in with the second line. But just for the sake of completeness, I included it. 6x plus 9. Please don't say that 3 squared is 6. It happens all the time. And even worse, don't say that 1 squared is 2. Okay, so then I've got x squared plus y squared plus 6x plus 2y. 9 plus 1 minus 5 is 5 equals 0. So that's exactly what we needed to get. As required. Cool. Find the equation of the tangent to C that pass through the origin. Okay, so what we've got here is we've got a circle. I'll draw a little sketch here. This is not going to be a great sketch, but there we are. So we've got some kind of circle like that. In fact, no, it can't look like that. It must look something like this. And then from the origin to that circle, there's going to be one tangent there and maybe another tangent there. We want the equations of those two tangents. Now, any line that passes through the origin is going to be of the form y equals mx. And so what we're going to be looking at is values of m such that y equals mx only intersects with the circle once. So there's actually going to be some discriminant work in this question, or the way I do it, there will be. So let's go ahead and do that. If we use that into the equation of the circle, well, what we're going to get is x squared plus m squared x squared, so that's the y term, plus 6x plus 2mx, that's the 2y term, plus 5 equals 0. 1 plus m squared, lots of x squared, plus 6 plus 2m, lots of x, plus 5 equals 0. So that is now an equation that's related to both m and the circle, and if you told me your favourite value of m, I could use that then to solve and find out what, if any, the x ordinates of the points of intersection were between the line you gave me and the circle. Now we want there to only be one solution for this, so we're going to consider b squared minus 4ac equal to 0. Okay, and so b squared, that is going to be 6 plus 2m all squared minus 4 lots of 1 plus m squared times 5, and we want that to be equal to 0. No real quick way to do this, so let's just expand it. 36 plus 24m plus 4m squared. Minus 4 times 5 is minus 20, so minus 20 minus 20m squared equals 0. Let's make it a quadratic with a positive m squared, so I'm going to get 16m squared minus 24m and then minus 16 equals 0. Let's make our life a bit easier by dividing through by 8, so 2m squared minus 3m minus 2 equals 0. This looks very factorizable with 2's and 1's. I think if I put a 2m there and an m there, and I make that one negative and that one positive, so m equals 2, m equals minus a half. Therefore, equations are y equals 2x and y equals minus a half x. Again, that's another really tricky question, and bear in mind we've only actually done the first 6 marks. We've got another 4 marks left to go. Okay, we're right on the home stretch now. So remember from the last part we had m equal to 2 and m equal to minus a half. We're going to use both of those to find the point of intersection. So let's first of all use m equals 2. So that will then give me, when m equals 2, I'm going to get 5x squared. I'm going to get 6 plus 4, so 10x plus 5 equals 0, which is the same as x squared plus 2x plus 1. Okay, and remember, the really good sign that we've done this right is this thing only has one solution, which is x equals minus 1. If I came out with 2 solutions, it's a bit of a giveaway that I've done something wrong. And when x is minus 1, y is equal to, we've got to look back here now, but I think it's minus 2. Okay, therefore point of intersection is minus 1, minus 2. And this is from m equals 2. Let's now consider m equals minus a half. I think we're going to get some similar answers here. So that's going to be 1 plus a quarter, which is 5 over 4 x squared. Then I've got 6, take away 1, which is 5, plus 5 equals 0. I'm going to divide through by the 5s and multiply through by 4, so I get x squared plus 4x plus 4 equals 0. And again, I'm only expecting one answer. If I had more than one, I'd be in trouble. So I have x equals minus 2. And when x equals minus 2, if you sub it back in earlier, you'll get y equals 1. So I can then say, therefore, point of intersection is minus 2, 1. Lovely. Okay, so that's a very tricky question to end. There's 10 marks available for that, but it is difficult. So yeah, like I said, take your time, pause the video, look back, rewind me if you want to listen to me talking about it again. Okay, and just got to do a plug at the end. So I'm making loads of these videos at the moment. So if you want to see more, particularly WJEC A-level videos, subscribe to the channel and you'll see them as they come out. Lovely. Thanks very much. Bye.